Right, today we're going to do 4.9 scientific notation. Now, this is a very difficult concept. Not necessarily difficult, but it's something that you're going to need to turn off all of your distractions around you and just listen, because this is something we haven't done before. Maybe you've done it in science, I don't know, but this is something that's very tricky, so please pay attention, write everything down in your notebook, and just really make sure that you're, again, paying very close attention. Don't be afraid to watch the video again. I know that takes time, you guys, but in the long run, it saves you time if you get it from watching it the second time, because then you don't have to come in early to come and ask questions, and it just saves you time in the long run if you just watch the video, the parts you don't get again. Okay, so first to start off, we kind of have like a chart like we did with our converting. I'm going to try to write very small, so please bear with me. So here's how we write scientific notation. Something like this. 5 times 10 to the 4th power is the same as 5 times 1, 5 times 1 with 4 zeros equals, well, if we multiply that out, it would be 50,000. Okay, so if we had 5 times 10 to the 3rd, so this is our scientific notation, is the first numbers. So 5 times 10 to the 4th is scientific notation. 5 times 10 to the 3rd is scientific notation. So that would be 5 times 1 with 3 zeros, or 5,000. Okay, 5 times 10 squared is the same as 5 times 1 with 2 zeros, or 500. 5 times 10 to the 1 power is the same as 5 times 1 with 1 zero, or 10, because remember, 10 to the first power is just the same as saying 10, or 50. 5 times 10 to the 0 power is the same as 5 times 1, because remember, 0 is the 0 exponent is the same as just 1. So that would give us 5. Do you notice how we're kind of dealing with decimal points here? Here my decimal point was here, then I moved it back 1 to here, then I moved it back 1 to here, then I moved it back 1 to here, moved it back 1 to here. So it's the 10,000ths, thousandths, hundredths, tens, and ones. Okay, so I'm just moving my decimal point around. So now here bids the question of, okay, what about if I have 5 times 10 to the negative 1 power? Okay, so remember, that's the same as saying 5 times 1/10, or 1/10 written like this. So it would be 5/10, or a half. See, again, I'm moving that decimal point. Moved it one spot. 5 times 10 to the negative 2 power is the same as saying 5 times, oops, I did that wrong. Sorry, guys, I put my decimal point in the wrong spot right here. I'm glad I caught that. Should have been 0 1/10. Okay, so now we're doing 0 and 1/100th, because if I did, this would be the same as 1 over 10 squared, or 100th, okay? 100th, or 0, please, I forgot to put my 0 here, and 0 500ths. Okay, what about 5 times 10 to the power of negative 3? If we do 5 times 0 and 1,000th, our answer would be 0 and 2 zeros. There we go. So again, I'm just moving that decimal point one spot. Okay, let's do, looks like we're supposed to do one more. 5 times 10 to the negative 4th power. Same as 5 times 0 and 0, 0, 0, 1 or 0 and 0.0005 ten-thousandths. Again, we're just moving that decimal point. One thing I want to draw your eyes to, so I'm going to put this as a whole screen. Notice how the decimal moves. Okay, and again I want to remind you too, if I have 10 to the negative, let's do 3. 10 to the negative 3 power, I would just do 1 over 10 to the third power, and 10 to the third power is 1 over 1,000. So it's a 1 with 3 zeros. Okay, 1 over 1,000 is 10 to the third power. So that's why we can write this as 1/1000ths, like a fraction, or I could write it as 1/1000ths as a decimal. So that's why I chose decimal, because it's easier to see things in decimal form, and I want you to do them in decimal form, but I just wanted to show you that this is how we would get our answer, and we are going to write it in decimal form instead of fraction form. Okay, so scientific notation is used to write very large or very small numbers as powers of 10. So if we think of the universe, and I want to figure out how far a planet is from Earth, I would want to use scientific notation because I wouldn't want to waste my time writing 21 zeros after a number. Okay, so that is the reason why we use scientific notation. It always has one non-zero digit in front of the decimal. And what it means by that is when we write scientific notation, I would write it like 5 times 10 to the fourth. It's always going to have a number right there. I'm not sure why it says decimal, but it's always going to have a number, a non-zero number right there. We need to drop extra zeros to the right of the decimal. Okay, so if I have 0 and 0.005 5,000ths, I don't need any more zeros to the right over here. Okay, so I just drop all of those because those are not important anymore. But we do need these ones right here because they hold our place. Another thing is we are always going to say times 10 to a power. We are always going to have times 10. We don't ever use any other times 5 to the 5 squared, or we don't ever use that. It's always 10 to a power. Okay, so let's look at a couple. It says convert between scientific and standard notation. Okay, so the first one is 3 and 21 hundredths times 10 to the 7th power. Okay, so that means I need to move my decimal point 7 spots to the right. Because if I'm multiplying by 10, I know that my answer is going to get bigger. Okay, so if I'm moving the decimal point to the right, my answer gets bigger. If I move it to the left, it gets smaller. Okay, so let's write our original answer here. 3 and 21 hundredths. Now I need to move it 7 spots. I'm just going to put a couple zeros down so I don't lose my spots because I don't want to move it the wrong amount. So I'm going to put 1, 2, 3, 4, 5. Let's do 6 for good luck. Okay, so I'm going to move it 1, 2, 3, 4, 5, 6, 7 spots to the right. So another way to help you on this is if I'm multiplying by, 10,000s, okay, my answer is going to get bigger. So if I go from 3 to 30,000, my answer got bigger, right? From 3 to 30,000, my answer got bigger. I know I want my answer to get bigger for this one. That's why I know I need to move it to the right. Okay, so my new answer is 3, 2, 1. And I have 1, 2, 3, 4, 5 zeros. Okay, So this is the number that they are describing. I'm going to put some commas in here so we can keep it straight. 32,100,000 is what we were talking about when we said 3 and 21 hundredths times 10 to the 7th power. Okay, so the key word up here, we said always one non-zero digit in front of the decimal. Okay, that 1 is the key. Okay, so this one you're probably wondering, well, why didn't they do 321 times 10? Well, if I took away 2, 10 to the 5th power. Why didn't we do that? That would have given us the same answer. Because in front of the decimal point right here, we only want one digit. We only want one digit in front of the decimal point. Again, you guys, I said there are so many little rules for this lesson, so please take your time on it. And again, we're going to drop our extra zeros. If there was a 0 here, we don't need it because we just need the numbers. Okay, we're going to do a million bajillion examples, so don't freak out yet. Don't ever freak out, but give yourself some time, okay? Okay, so here's number 2. Number 2 says 5 and 9/10. Remember, we can only have one number in front of our decimal point times 10 to the negative 8 power. Okay, so negative means we're going to move the decimal to the left. So if I bring down my 5.9, I'm going to add some zeros so I don't get in trouble here and not know which one I'm supposed to go to. Okay, now I'm going to move it 8 spots to the left. 1, 2, 3, 4, 5, 6, 7, 8. Hey, that was a perfect amount of zeros. So my answer is, and please you guys don't tell me this is an answer. Don't write, I don't want to see all of your jumps and 2 decimal points in your answer. I want you to neatly write your answer down. 0 and 1, 2, 3, 4, 5, 6, 7 zeros. 2, 3, 4, 5, 6, 7 zeros. Then we have our 5, 9. Okay, so this would be our answer for this one. All right, let's try another one. 3, 1 and 0, 0, 6 times 10 to the 9th. Okay, so again, I just write down my original number, 1.006, or 1 and 6 thousandths. And now I need to move it 10 spots to the right, so I'm going to add some zeros to the right so I don't lose my spot. 9 spots. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. Okay, so here's my answer. 1, 0, 0, 6. 1, 2, 3, 4, 5, 6 zeros. Okay, so I'm going to put my commas in. So 1,000,000,006,000,000 is what our answer would be. So here's my answer. I'm going to put a box around it so I can know. Again, this is your work. So you do need to show this so I can see what your work is. Okay, so let's do number 4. Now we're going to go backwards. We're going to put 54,500,000, and we have to write it in scientific notation. Okay, so I'm going to look at my numbers at the front. I know I can only have one number in front of my decimal point, so I know my number is going to have to be 5.45, or 5 and 45 hundredths. Okay, so now I'm going to put my imaginary decimal point here. And I'm going to move it from 1, 2, 3, 4, 5, 6, 7 spots. So I know I'm going to have to multiply it by 10. Now, I want my answer to go from small, 5 and 45 hundredths, to big, 54,500,000. So I know that I need to do 10 and 7 needs to be positive. Okay, so here's my answer for this one. And here's my work right here. Okay, so let's try another one like this. Number 5 says 0 and 0, 0, 0, 2, 1. Golly, what would that be? 21 ten thousandths? 21 hundred thousandths? Yeah, 2100 thousandths. Okay. So now I'm going from a little number, and I need it to get bigger. Okay, so I want my decimal point to be right here. So I want it to be 2 1/10 because I need that one digit in front of the decimal point when I'm writing it in scientific notation. Then I multiply it by 10. That's always going to happen every single time. Times 10, times 10. Okay, and now this one looks different than the first one. The last time I went from a big to a small number. Now I'm going from a small to a big number. So I know my answer is going to be a negative. Okay, and I need to move it 1, 2, 3, 4 spots. So my answer is going to be 2 1/10 times 10 to the negative 4th power. Negative 4 power. Okay, so a rule of thumb, if we're going from decimals to a bigger number, it's going to be negative. If we're going from a huge number to a smaller number, it's going to be positive, our exponent. That's kind of the only tricky part. And again, if we look at it from, okay, I need to go from 2.1 to 2100 thousandths, my number has to get smaller. So to go from here to here, and my number has to get smaller, so it has to be a negative. All right, let's try another one. Like I said, we're going to be doing a lot of problems on these. So if I have 723,000, I know my answer is going to have to be 7 23 hundredths times 10. Now I have to figure out how many spots I need to move it. So here's where my decimal point would be, but we don't need to put it there because we just know it's there. And I have to move it 1, 2, 3, 4, 5 spots. Here's how I want you to look at it. I went from 7 to 723,000, so that's a bigger number, so my answer is going to be a positive. My exponent is going to be a positive number. Okay, let's try another one. Okay, number 7. Here we go. This one has a lot of zeros, so pay close attention. 0 and, let me count them, 1, 2, 3, 4, 5, 6, 7 zeros. 3, 4, 5, 6, 7 zeros, and then it has a 5. Now this one's easy because we only have one number, so I know I need to write 5 times 10. I'm going from 5 to 5, a teeny baby little number, so I know my exponent's going to be a negative number. Okay, so now I need to figure out if I move, how many spots I need to move, okay? 1, 2, 3, 4, 5, 6, 7, 8 spots. So my answer is 5 times 10 to the negative 8th power. Okay, how are we doing so far? I hope you're following along fine. This is the last section of this chapter. So now we have, you guys, this is a lot of notes too. I have 2 pages of notes in my notebook, so I know it's going to be a lot of notes in your notebook as well. Okay, so adjusting to scientific notation is our new heading. Okay, and what that looks like is if let's say something put 16 times 10 to the 5th. We know, hey, that's wrong because we can only have one number in front of the decimal point. I need my decimal point to be here, so really that needs to be 1 6/10 times. Okay, I moved it back 1, so that means I need to times it by 10 to the 6th power. Okay, watch that again. I went from 16 times 10 to the 5th. So if I want to get 16 times 10 to the 5th to be the same thing, I have to move it back 1 and 6/10, and I need to move that decimal one more time to get it to equal the same number. How we can, this is kind of a different type of thinking, you guys. You're going to get these questions on there. It's going to say write each number in standard notation, in scientific notation, and it's going to give you the wrong numbers. So how you can kind of cheat if you forget, oh God, which way am I supposed to do it? Am I supposed to make it times 6, times 10, or sorry, 6, times 10 to the 6th power? Or is it supposed to be 10 to the 4th power? Is it supposed to be 10 to the 5th power? What am I supposed to do? So we can just write it out. I can just write it out as 16 with 5 zeros and 1.6 with 6 zeros. Okay, and then I need to move it 5. 1, 2, 3, 4, 5. So I would get 16, 1, 2, 3, 4, 5, 1.6 million. And here I need to move it 6. 1, 2, 3, 4, 5, 6. So I get 1, 6, 0, 0, 0, 0, 1, 2, 3, 4, 5 zeros. And I can put my comma, and I get the same answer. So just check your work if you're not 100% sure. This is a good tip for doing it on your homework or doing it on your quiz. If you're like, oh, I just don't know if it's right, just write them all out. I mean, sometimes it might be a pain if you have like 21, 10 to the 21st power. I mean, that would be a pain. But then you know you got the answer right. And that, to me, is worth the extra time of sitting down and making sure that you have everything. So what about this one? What about if they gave you one that says 0 and 203 times 10 to the 9th power? Again, a flashing light should go off in your head. There's supposed to be a number in front of the decimal point. Okay, so it should be 2 and 300ths times 10. Okay, now this is where it gets a little bit tricky. So I moved it to the right, so that means that I need to put it 10 to the 8th power. Okay, I made the original number bigger, so that means my exponent needs to be smaller. It's kind of like opposites. Whereas if I made my original number smaller, like with the 16, we changed it from 16 to 1.6. I made my original number smaller. We need to add exponents. Okay, and if I went from here, I did 0 and 203 to 2 and 300ths. I got bigger, so I need to subtract exponents. Okay, so here would be my answer. Let's do another one. Number 3 is 7,243 times 10 to the 12th power, Again, now this is one that would be kind of a pain to have to write it all out, but we have a little trick we can use. So what we need it to be 7 and 243 thousandths times 10. Okay, so my original number was 7,000. I brought it down to about 7. So my number got smaller. So I'm going to have to use this top trick. So we need to add the exponents however many spaces we moved it. I moved it back 1, 2, 3 spaces. So I need to add 3. So I would get it to be 10 to the 15th power. And you guys, you know, you have had a hard time studying for tests. This is something that I would really pay close attention to and study to make sure I knew it on my test. Okay, don't just try to get your way through the homework. Don't just try to get your way through the test and maybe I'll get lucky. This is something you're going to need to study. Come ask questions. Make sure that you get it. Okay, now we're going to do switch gears again. Now this one is comparing and ordering numbers. Listen carefully here. Order from least to greatest. You guys, reading directions is so important. If it would have said greatest to least and you ordered least to greatest, we would have been wrong. Okay, so make sure you take your time, you read all the directions, especially on the homework, because there are so many different pieces on this. I don't want you to get them wrong, okay? just because you read the directions wrong. Okay, so the first one we're going to do has these three numbers. 526 times 10 to the 7th, 18 and 3/10 times 10 to the 6th. Some lights should be going off in your head because these are not written correctly. 0 and 98 thousandths, sorry, times 10 to the 9th. Okay, so we need to write them correctly to be able to compare them. Okay, so let's write them correctly. 5 and 26 hundredths times 10. Now I went from 500 down to 5, so I'm thinking of that 16 down, so I need to add those exponents. I moved it 2 spots, so I need to do 7 plus 2, so I need to get 10 to the ninth power. And then for this one, I need it to be 1 and 83 hundredths. Okay, and again I got this 2 because I had to move the spot 2 spots to get to my answer, 5 and 26 hundredths. Okay, now this one I'm only moving 1 spot. I went from 18 down to 1. So I know I'm going to need to add the exponents. I just need to add 1 though because I only moved 1 spot. So 10 to the 6th plus 1, or 10 to the 7th. Okay, and then here I need it to be 9 and 8/10. And I went from a smaller number to a bigger number, 9, 0 to 9 basically, so I got a lot bigger. So that means I need to subtract my exponents. Okay, and I moved it 2 spots. So I have to do 10 to the 9 minus 2. Oops, I don't need to write that down though for my answer. 9 minus 2 is 7. Okay, now we can just compare them. So what's the biggest one? Well, obviously this one is because it's got 9 zeros instead of 7 zeros. So this is our, I'm glad I looked at that one more time because I was going to put a 1 there. This one's our biggest one, and greatest is the last, so we're going to put a 3 here. Okay, so now I'm going to compare 1 to 9. Obviously, 9 is going to be bigger. Okay, so 9 should be 2. And the middle one is 1 with 7 zeros, so that should be a 1. Okay, you guys, that's why we make sure that we have it in the correct scientific notation, so because then we can just look at it and we can know which one is the biggest. We don't have to sit here like with these guys and convert and write it all out. We just change it into scientific notation and boom, we can look at it. Okay, so the first thing I'm going to look at is exponents. 9 is the biggest exponent. So I know that 9 is going to be the biggest number. Okay, then these two both have the same exponents. So then I look at the ones place on their numbers. So I know this is the second biggest, this is the smallest, but they want us to order from least to greatest. Okay, so again, ordering from least to greatest. Here's our number 2. 8 times 10 to the -9th. 14 and 7/10 times 10 to the -7th. 0 and 22 hundredths times 10 to the -10th. Okay, so let's make these into correct scientific form. Scientific notation. This one's good already because we have one number in front of the decimal point, which is an 8. So we can keep this one. 8 times 10 to the -9th. Okay, so we know these are going to be very small numbers. This one, I need it to be 1 and 47 hundredths times. Okay, so if I'm moving it back, I went from 14 down to 1. So that means I need to subtract. If I go from a bigger number down to a smaller number, I need to add. We do the same exact thing as if they were positive. Okay, so I have a -7. If I add 1 to that -7, don't tell me -8, it's going to be a -6. Times 10 to the -6. Okay, and then I need this one to be 2 and 2/10 times 10. Okay, so I moved it. I went from 0 up to 2. So my number got bigger. That means I need to subtract. So I need to do negative 10 minus 1 because I moved it one spot. So it will be to the negative 11th spot. Okay, so from least to greatest, which is our biggest number. Okay, so now we're doing negative. So now we have to think kind of opposite from what we thought with the positives. For the positives, we looked at the biggest number and we were good to go. We knew that was the biggest exponent was the biggest number. So now here, because it's negative, we can it still is the biggest number, but it just kind of flips because they're negative. So I know that this is going to be our smallest one. So for this one, we can write it as 1 because that's our smallest. Then I know that this is going to be the second smallest and this is going to be the biggest because negative 11 is the smallest number. Then it would go negative 9, then negative 6. I'm just looking at the exponents. Okay, if I got my number line out, 0, I'd have negative 6, negative 7, negative 8, negative 9, negative 10, negative 11. This is the smallest number, then it would go to this one, then it would go to this one. Okay, so again, I've got 1, 2, 3. When you write this down in your book, you're not just going to be able to write, for doing your homework, you're not just going to be able to write 1, 2, 3. You would have to go back and write our original problems, our original numbers. Okay, so for this one, my smallest would be 0 and 22 times 10 to the negative 10th. Then it would go 8 times 10 to the negative 9th. Oops. And then it would go 14 and 7/10 times 10 to the negative 7. Okay, so this is how you write your answer on your homework. And sorry guys, we are not quite done yet. Now we get to talk about multiplying. They just really crammed a ton in here. Multiplying with scientific notation. Okay, and again, you guys, the more practice we get with this, the easier it will be. So that's why you do have to do a lot of problems, because the more problems you do, the better you'll get at it. It's just like a sport. The more you practice a sport, the better you get at it. Same goes for math. Okay, so here's a review of the commutative property. Oh, you remember those lovely properties we did at the beginning of the year? Commutative property. I can't quite fit it in there. That word is property. Okay, so if I did 3 times 2 times 4, okay, it's the same as if I did 3 times 4 times 2. Okay, so it doesn't matter what order I multiply in, because it's multiplication. As long as I'm multiplying them all together, we're good to go. That's not the same for subtraction and division, just multiplication and addition, they both work. Okay, so here we go. If we say to multiply 4 times 10 to the 4th power times 6 times 10 to the 6th power. All right, so what I'm going to do is I'm going to take the first two numbers and I'm going to multiply them together. 6 times 4 is 24. Times 10, then I would add my exponents. Just be like if I said, what is 5 squared times 5 cubed? Remember, when we multiply them together, all we have to do is add the exponent, so it'd be 5 to the 5th power, okay? We learned that a couple lessons ago, so this is just kind of a little bit review. So I'd have to add 6 plus 4, and I get it to the 10th. Okay, but now I'm saying, okay, well, that's not in scientific notation. It needs to be 2 and 4/10. So if I went from a bigger number down to a smaller number, that means I need to add however many spaces I jumped with my decimal point to the decimal point. Or sorry, to my exponent. So I jumped one spot back. So this answer would be times 10 to the 11th power. Okay, so again, when we went from 16 down to 1.6, I said we need to add those jumps to the exponents. So that's why I added here. Let's try another one. Okay, number 2. Again, you guys, these kind of go in the order of your homework. So just really pay attention, and if there's a question you have, just go right back and watch these videos again, and I'll show you how to do those steps for those. Okay, so here I have 7 and 1/10 times 10 to the negative 8th power times 8 times 10 to the 4th power. Okay, so I have to do 8 times 7 and 1/10. 7 and 1/10. 56. Bring it back one spot because it was one spot here. Okay, so my answer is 56 and 8/10. Then let's add these add these exponents together. So I have a negative 8 plus 4. Okay, so I have $4, but I owe $8. So if I give that $4 I still owe them $4. So my answer would be 56 and 8/10 times 10 to the negative 4th power. Okay, but again, we're not into that correct formula for scientific notation. I need to move it back one. So I'm going from 56, a bigger number, to 5 and 68/100ths, a smaller number. So that means I need to add my exponents. I jumped once, so I need to add 1. A negative 4 plus 1 would be times 10 to the negative 3rd power. All right, you guys, this is a very long video. I'm going to put the quiz questions right here. I will do a couple examples from the book, just so you can get a couple of homework problems done if you want to keep watching. Thank you for watching this far. Keep watching if you have any problems. Okie dokie, let's do number 2. Let's go with number 2 from your book. It's on page 219. Number 2 says 555,900,000. Okay, so I know I need to have one number in front of the decimal point, so I'll just start with that. And then I just write all of my numbers. 559. Okay, I don't need all those zeros after the decimal point, so that's where I stop. Then I multiply it by 10. Now I need to figure out how I did it. Okay, so here was my decimal point. I needed to move it back. 1, 2, 3, 4, 5, 6, 7, 8. 8 spots. Okay, so going from 5 up to 555 million, huge number, is getting it bigger. So I know my answer needs to be positive, or my exponent needs to be positive. So there's my answer for number 2. Let's go you try number 4 on your own. We'll go number 6. Okay, number 6 says 0 and 409. Holy smokes, they really are making me think here. Tens, hundreds, thousands, 10,000s, 100,000s. Okay, so 409 100,000ths is our number that we're having to do. Okay, so again, I'm just looking for getting rid of all the zeros. I want it to be 4 and 900ths. Okay, so that's where I'm looking at. Times 10. So now this one, I'm going from 4 down to 0. So I know my answer is going to be negative. My exponent's going to be negative. And I moved it 1, 2, 3, woo, I almost went too far. I moved it 3 spots, so it's going to be to the negative 3rd power. Okay, what helps me is to look at my answer here and say, okay, I started at 4, went down to 0, so I need to go negative. Negative to get to my answer. Okay, so those ones should be good. Now let's go to number 8. And 8 says, write each number in standard notation. Standard notation is just regular numbers. It's not scientific notation, just regular numbers. This is standard and this is standard. Okay, so those are standard notations. So here we have 5 and 94 hundredths times 10 to the 7th power. Okay, so all I have to do is I have to write down my number. and move it to the right 7 spots. 1, 2, 3, 4, 5, 6, 7. Now this is why I said I like to add zeros beforehand, because now I'm like, okay, do I add a 7 where it dips? Or sorry, do I add a 0 where it dips, or do I add a 0 where it comes up? Where it dips is where you add a 0. 1, 2, 3, 4, 5 zeros. Okay, so this answer should be 5, 9, 4 with 1, 2, 3, 4, 5 zeros. Okay, so I'm going to put in my commas. Please put in your commas, you guys. That makes it so much easier for me to correct. So do not forget your commas. I don't want to have to hand it back to you and say, put your commas in. Just do it the first time you do it, okay? So there's our answer for that one. These ones should be pretty simple. If it's a negative exponent, we move to the left. Move that decimal to the left. If it's a positive exponent, we move that decimal point to the right. Okay? So these ones should be pretty easy for us to get through. If not, come ask me a question about it. Okay, so for number 14, this is where they're going to write the scientific notation in incorrect form. Okay, so number 14 says 0 and 9/100 times 10 to the 12th power. Better make sure that looks like a 12 and not a 72. Okay, so it needs to be 9 times 10. Okay, so I went from a smaller number up to a bigger number. That means I need to subtract 2 spots. So I should have 9 times 10 to the 10th power. Okay, we wrote those little rules, you guys. Please put a box around them or something so that when you're doing this, you just look back and say, what was the rule? If I go from a small number to a bigger number, I subtract. If I go from a big number to a smaller number, I add my exponents. Okay, so here's our answer for number 14. There's only one more, so I'm going to have you do 16 on your own. Okay, order from least to greatest. I'll do one of these. Number 18. And it says 16 times 10 to the 9th. 2 3/10 times 10 to the 12th. And 0 and 65 thousandths times 10 to the 11th power. So again, we have to make sure we're writing them in actual scientific notation. So this one would be written as 1 6/10. Okay, I went from 16 down to 1 6/10. My answer got smaller. That means I need to add to the exponent 1. So this would be times 10 to the 10th. Okay, so here I can keep it the same. 2 3/10 times 10 to the 12th. And then here I need to move it because I need 6 5/10 times 10. Okay, so I went from 0 up to 6. That means I need to subtract because I got bigger. So I need to subtract 2 spots. So 11 minus 2 is 9. Okay, so I'm going to reread my directions here from least to greatest. Okay, from least to greatest, well, I know the smallest one's going to be here because it's only got a 9. Then I'm going to go to the 10. That'll be my second. Then I'm going to go to the 12, which will be my biggest number. Okay, so when I write my answer, though, I need to write them how they wrote them in their original format. So I'm going to go back. My first one should be 0 and 65 hundredths times 10 to the 11th power. Then it should be 16 times 10 to the 9th power. And then it should be 2 3/10 times 10 to the 12th power. Okay, so from least to greatest. Okay, why don't we try number 22, and this will be the last one that we do together. I'd like you to try and get the rest of them done yourself. Okay, so for 22, it says 4 3/10 times 10 to the 3rd times 2 times 10 to the -8th. Again, I take my front numbers and multiply them together. 4 3/10 times 2. 3 times 2 is 6. 2 times 4 is 8. bring it back 1. So this one already is in our correct form, 8 6/10. That's exactly how we would write it if we needed to. Okay, so now this one's kind of easy because all I have to do is add my exponents. If I have $3, but I owe you $8, that means I can only pay you 3, but I still owe you $5. Okay, so here would be our answer for number 22. That will be all for the video for today. Thank you for watching.